Okay, so today we'll learn more about more detail about the messages and stuff. We'll use a PC as a wireless data logger, and actually we're going to do wire and wireless kind of at the same time. So right now is your COM1 port, which is in the back of your PC, is hooked up to the black connector, the good old mini jack black connector. It goes to your bot right now. So we're ultimately using COM1 for wire connection, and then we use a dongle with the 6100 of the wireless. So we'll alternate between the two because that's some things I want to show you essentially coming up. It's different between print line and when you TXD something, when you transmit the data. So that need to go first, and then we'll go into the detail of a Visual C program on the PC that act like a data logger. Basically, it just sends wireless message out to your carbot and ask, hey, what's your near-infrared sensor? And send it back to me. Okay? And so the point is you can learn C a little bit quicker now, and then later you can build up to like a wireless network kind of station, which could be, it could be anything. You guys are not in ag engineering, but let's say you are in bioengineering. Maybe you work on something where people nowadays pretty much kind of wear a little data logger that could collect data on them, like pulses, how they walk, that sort of thing, and then transmit home. It is smaller, much smaller version of it, but the basic principle is there. They use more fancy communication skill because probably go through the phone and all of that stuff, but at least you got a chance to work it here. So topics, make PC into a wireless data logger. It can transmit and receive data to it or from one carbot. So on the carbot side, it runs a software piece of code called wireless carbot.tsk. It's inside your TSK folder there. So if you already put it up on the desktop, that's where it's going to be. The wireless robot is a big folder. Essentially, it has a Visual C project file and all kind of things there. Don't start on it yet. It's kind of complicated to get through that one. So on the CM side, that means what? There's a ZigBee inside. Oh, I forgot that. Need the camera going. So on the carbot side, you can see there. So as usual, we have the thing in there. So this one is Z14, whatever carbot you guys have. We need to deal with that. Okay, and then while we're here, so we also have the Zig dongle to the Zig2 serial, and then a Z100 there. So remember how we go to the PC manager to change the ID so they talk to each other? We'll have to do it again today because whatever is here, need to talk to Z14 only and not talk to the rest of them. So we're coming up to that. Oh, it's going to take at least two lectures to go through this chapter. So on the PC side, like I said, we have the USB 2 dongle, the Zig2 serial little board here, and the Zig100 in there. And then we'll use the Visual C programming via Visual C Express. The real thing this year. Actually, to be correct, I need to update this one in 2012 because they just update all our computer to that. So it's not 2010 anymore. Luckily, it still functions the same, but I show you as we go through the updating here. And then the wireless robot.zip, that's up in the ELC already. Okay, so later when we do project where you may probably want to do this, you can install Visual C Express at home and start from this one for home use. Okay, so first we need to get these guys set up to one-to-one mode. Okay, and so need to pull up that PDF that have all the ID for all C100. I do the same for mine. So I don't know which one is in here right now, and I know I have Z14 over here, so I have to go to Z14 and do it too. The key thing is right now, remember what? Either Carbot actually is connected to COM1 now. Okay, so so at least on the Carbot we know it's Z14 or whatever. So therefore, this number is listed in the PDF file. So I'm going to go to the PC Manager tool to figure out what I have here. And you guys need to figure out what is on your dongle and change to the Z14. So let me pull that one up. So Z14 on my CM5. So it for me, like for example, I need to make it my USB dongle to here need to talk to 14856. So let's minimize that. I need to go. You gotta remember to do that, right? Lab 310 application only. You see the Robo Plus. So get Robo Plus up. Ready? Right. So Robo Plus Manager. Had to find the right COM port for it. It's not COM1, but the COM1 is the one that is wired. So for me, it looks like my dongle, USB dongle here is on COM3. So select COM3, but don't connect it here. Go over to ZigBee serial management. And it's there. So we need to do the ZigBee setting. So remember what? Click on it, and then remember it will synchronize on release. So just go ahead and click OK here. Make sure you're firmly down on it and just release cleanly. If that connection good, it's out here. Okay. Wow. I look like I need to buy my lotto ticket today. Look at that. Might happen to be set up correctly already, and I just picked one at random. Okay. So I'm good. One of them need to be changed. Yeah. So you need to find the carbot, which is the middle column here. Whatever your carbot is, have that number, and go in there and modify it. So I leave it here until you guys caught up here. Let's see. I'm just going to hold the recording for the moment. Okay. So I'm back recording again. So my ID, basically the ID on my little Z100 chip here is 14857. Okay, and that one you cannot change. You can only change the remote ID. That means whatever ID that you were supposed to talk to. And Z14 is my carbot, and it's just by luck of the draw that Z14 is 14856. So somehow I was lucky. They're already matching, so I didn't have to modify anything. So that's that. So that part is finished as far as setting up the proper ZigBee100 on the USB dongle, i.e. the PC will talk to COM3 wirelessly to the carbot. So that's that part we just did. Now I need to go to COM1, which is the wire, so that I can check if Z14 is properly set up. Oh, I'm on the wrong side. Yeah, that's why I didn't see it. COM1. So you need to, which one is wireless COM1, okay? All right, so its ID is 14836 because that's Z14 right here, which is correct. It needs to talk to 14857, which it happened to be doing already, okay? So that means my carbot is set up to talk to this wirelessly to this USB dongle through COM3. And then also it talk wire with wire. We are COM1 right now. Okay, we should done with that. Okay, just keep that one up. Soon we're gonna need to load that Robobus task code into it. So let me go back to the PowerPoint. So we just do the manager and we done that. And then let's talk about the wireless carbot and what's doing there first. Okay, so go into that folder you have already on your desktop, PSP file. If everything is okay, it should way down the bottom because you have alphabetical by name. So wireless cardboard, let's pull it up. Okay. So first, remote control ID. This one is an old one. Obviously, that's not correct, but I already got it set up properly in the manager already. So you don't want to mess around with that. Just comment it out because we already got it set up properly inside the cardboard. Call initialize motor speed, set speed. Basically, this piece of code is just from that RC cardboard where you can make it go up, down, left, right, and change the speed also. That's just the one. So basically, you have a main endless loop. It pick up from the RC100. Okay. So remember what remote control XD means just to receive the data. The poor old brain in the cardboard have no idea if it come from the wire or from the remote wirelessly through Z100. It have no idea because the way they designed the motherboard on it, it share the same kind of communication channel. So you have to either go wire on it or go wireless, not together in the same through here. So right now so basically it has circuitry that detect if there is a connection push into the mini jack, you know, oh, I'm expecting to receive something by wire. If you unplug it and then it check, oh, I'm supposed to receive through my own little ZigBee chip. Okay. Why? Because the controller didn't have enough COM port. They had only 2 COM port, one to talk to only its old servo and sensor, and one to talk to the outside world. Okay. So if you have later controller, other controller, you're gonna find out that very often they come with 4 COM port. Okay, so you can even have one to take care of your own bot and sensor. You can have one talk to the PC, one talk to your hardware debug board or something. Much better. And then you can debug in real time, check things. Ooh, that's the way to go. But not this one. Okay, so this one is older and cheaper. So remember, right? Mark on XD, it's just actually gonna pick up something. It have no idea if it comes from the virtual, that means through the PC, or from the real physical controller to anything. It just receive. If the button is 0, that means nothing, just stop. Else, it find out, if it's, it filter with 15, so it know which direction. So you can do up, down, left, right. If it found out that you're sending up, it's gonna go forward, 2, 4 left. So basically, this piece of code is just like from the RC100. So that means I can be able to send it there. And if it's happened that I'm pushing 1, 2, or 3, I'm going to change the speed on it. Okay. So that's just like I don't know. What is it? Simon 1 or something? I forgot. What, Simon 1 or 2? Probably 2, isn't it? No, Simon. Yeah, could be a Simon 2 or something. All right. So the only thing I added was this here. I say, okay, pick up the IR center, save into center IR, and then one is print with line. That means it's gonna print out from the output, right? The little output window that we've been using all the time. It's gonna print that value. Also, it's gonna TXD it. Okay. So remember, TXD is the one that remember in bot to bot master girl work. That's the one that's sent over to the master, sent to the slave. And then if you do closed loop, which you got been avoiding doing it, is the slave bot send data back. But TXD is to send the data out. So you say, wait a minute, is there a difference between print with line? Because you've been using print with line to kind of debug things, right? It's sending back to the wire into the output file. Can you do it? We'll find out what's the difference between print and TXD. Okay. So I print that one. So basically, it print center line and jump over and print the remote control XD. So print with line first. So I print out the print with line, center with line. So I print out the center IR reading. Go to the new line. It's gonna try to print out the TXD to see what it's gonna look like, and then print 0, and then it come down, and then it's endless loop again. Okay. So this is what the wireless call bot do. So right now what we'll do is just use wire, okay, wire connection. And also we're going to use a virtual RC100 to see what's going on, okay? So therefore, make sure you choose COM1 because we're going to use this wire. CM5 should be there already, and then just download this guy, assuming your bot is still on. And we'll go to view output of program. And then it's the same thing. Make sure it's in mode, play mode, and start running. And I need to, okay, so I need to put my virtual RC up. Then we push so it stopped running here. And so that you can look. First, remember, it's supposed to print out the value of the IR. And let's reclose this so that I can scroll it up. Let's explain a little bit. Okay. So call it print center IR, and then TXD center IR and print line 0. So the first number here is what is reading on the IR because right now the front has nothing. I didn't block it or anything, so it's reading 0. And then this U here supposedly corresponds to print with line center IR. But you notice print ZU supposed to print 0. And then this 0 here just so that it print line with 0. Maybe I should change that a little bit so that it's a bit more obvious. Let's say it print out 111. So okay. You don't have to, but I'm going to change it so that's a little bit more obvious. Okay. So I push to start. Okay, that you use 111 again. So as I move my hand, you see it start changing. And let me stop it because it scrolled too fast. So I can look at what's going on here. Okay. See, my hand was out in front of it, so read 0. But essentially every time I do the TXD, it print out U. And then when I stick my hand closer, let's see, it start changing. Up, here we go. Okay, when I stick my hand closer, it starts seeing 3, 4, 7, and stuff like that. And then, this one come up, 12. And 111 is just fixed, okay? But you start seeing when I get closer, I start reading 255. But this TXD is always U. That is a problem, isn't it? So it's supposedly sending it out. Question, yeah. Yeah, sometimes U, sometimes even a curly bracket. Yeah, and then there's some kind of an unprintable character in there. It couldn't print. Okay. UX, UI. What the heck is going on? Okay, yeah. Okay. So let's leave it here. Let's capture. Hang on. Let me pull it down. So I'm trying to capture it so I can make comment on it at the same time. Yeah, this is good. Let me get my pen. Capture that. Yeah. So this is what we need. Okay. So first, yeah, blue is fine. So when you print with line center IR, it print this number correctly. That's the reading from the IR center up front here. Okay, so that's great. But anytime you tell the remote con TXD, it print out U, sometimes have other thing in it, it's weird. And then the 111 just there so that you know, it still does know how to print line correctly. It just, what is going on? Okay. So this is your result when you do, basically one way to look at it, this is the result when you send a data through TXD into a Windows COM port. Why? Yeah, I already got captured that, so let's close this one because they won't let me. Why? We had to go back quite a bit. way back in down foundation. Let's see if I can find it. Here we go. Foundation. When you hook the wire to the PC, to the bot, remember it talked to what? RS-232. So that is a different protocol than ZigBee wireless. Okay. So people in there already, let me go to that. So in this program output monitor, it expects that you are sending me data according to the RS-232 protocol. So whatever your data, as you know, when you send data, it's really just 1 and 0, but you have to agree on some kind of format and protocol. So when you do a print line and the number, it print out that number in the RS-232 protocol. That means what? It actually sends the character 1, 3, and 5 for the number 135. Send that character in the clear in RS-232. Because this output monitor here is all designed for that. It's like, hey, that's what I got. Because all it does is just pick up a bunch 0 and 1, and I'm expecting to be a certain format, and then I'm going to print it in a certain format. So therefore, everybody matched. The bot sending proper format, the PC expect the proper format, everybody happy. They print out the proper things. When you do the TXD, though, you guys do ZigBee protocol. And you remember the ZigBee protocol? This is a ZigBee protocol. So when you TXD, it sends out that whole packet. Remember, that packet has 6 bytes. The true data is what? The low byte and high byte that they split in half, plus its complement or its inverse, plus FF and 55. So it sent out a whole lot more than just the raw data, like when it does doing print with line, the number. Okay, got it? That's why the program output monitor on COM1 is expecting RS-232 protocol. That means only probably 1 byte having the character 135 in there. But because you're using the TXD command, it sent out a huge 6 byte packet. So this guy over here, the PC window, expect it to be in the same thing before. So that's why I say, I don't know what this is. I'm just going to interpret all the 0, the 1 as best I can. It start printing out U, W, U, X, and all that, depending on the data you send in. Okay? So what is a take-home lesson is, when you TXD it, it really sends out that 6, it have your data in it, it chop it up a certain way and send a 6 byte over packet. That means in order to do it properly, your output or whoever you receive on the PC end better know how to take that packet, take it apart, reassemble the right data, and print it out. That's the purpose of the Visual C program on the PC that we're going to look up next, because it has to do that. Now, you remember when we did the little application on the RoboPlus Manager? Yeah, we can do this. I had to make sure on the COM3. Remember, we play with it, we send the data, but the receive data. So I don't know, a few weeks ago, it did send it correctly, remember? It received and sent out correctly. Why? Because this little Windows Zig2 serial, little software actually know that, hey, this is a 6 byte packet, and I know how to unpack it so I can display properly. So what we're doing, we're going to do a Visual C, not graphical like this, but a simple command line thing where we reproduce this functionality. That's what's going on the Visual C project. Okay, so we're getting deeper into the nuts and bolts, right? So previously, all we do is just drive the car around. Now we're going to open the hood, look into it. Because remember, this class supposedly embedded robotics, so we're going to go down. Okay, so that's what's going on there. All right. So that's what I wanted to show you that, hey, that's what's going on. Okay. Now there's a new trick I haven't shown you yet. But right now COM1 is in here, is in wire, right? But remember, I also have COM3 going through the wireless. So we'll show you a trick where the wireless will go to the CM5 and coming back this way. Okay? But first thing we need to do is we need to let the carbot know that, hey, you don't have no more the mini jack in there. So it will switch to its own ZigBee circuit, so we say. So unplug that. And then remember, no longer COM1 in here. Go to COM3 because that's where my USB dongle is. Whatever for you is. Is it COM3 too, or it could be different? I don't know. You still okay? We're lucky for us this time. So it's synchronous. Sometimes it could be because window. You put any of these devices in, it give it a different number. Okay, so make sure you're on COM3 and CM5. Okay, but we won't need to download the code anymore. This is weird. You go to that view output of program, hook it up. Now what it is, because this output monitor program is talking to COM3, it's really talking wirelessly to the carbot. Okay, but as far as concerned, it's the same thing. It doesn't know the wire or not. Okay, so right now it's actually that, and then you can do the same. You make sure to go to play mode here, and you start the program. Okay, and I start seeing those things again through the wirelessly now.
Yeah, it's pretty cool.
Huh?
It's pretty cool. I got like a pound sign.
Oh, yeah, all kind of crazy number.
Yeah, that's cool. Backslashes going on.
Oh, yeah. It probably, because you put your hand in front of it.
The asterisk.
So you see, at the number I read 255 now, and I go out, it gets smaller, but at least on mine, it's always you use something. Oh, yeah, I got pound sign hash. Okay, yeah. So basically, the poor member guy said, what are you trying to send me here, guy? I don't know what to do. Because it's all 1 and 0, so you kind of print out garbage. Okay? Now this is cool now. If you click this one on, because remember, there's a piece of software that still accepts these commands. It's still doing it. Let's see, I set up my speed to 2. I can do all that. And it's wirelessly. Oh, go forward now. Okay. And the thing is, remember what? It takes some long time, man. There's some kind of delay there. See that? Usually, in theory, I release it. It should stop. But sometimes you see it didn't catch it.
Yeah.
So there's some delay. So it lost some packet.
I did too.
Yeah, sometimes lost packet. So what you see there is ZigBee. Even remember that it have that it chop out the data set into 2 pieces, inverse that. So it does error checking. But ZigBee, you can see lots of interference here. Sometimes it lose packet. When it lose packet, it didn't stop because we did set. The thing is, anytime you release it, it sends a 0 only one time. This time it's okay. It's good. Now it's good. I don't know. So this is, but the thing is, so that you know, ZigBee is sometimes it does it and sometimes it doesn't do it. Okay, here we go. Yeah, it just did that. It never sent a 0. Now it's 0. Okay.
There it is.
Yeah, it got yeah. It lost a packet, so it took the previous command and still on doing that until you click on something.
It's running away.
Running away. Okay. So you can see that immediately when you do communication control, it's very hard. You have to write a piece of code in there to take care of what happened if I don't receive data. How do I know I don't receive data? Yeah, it's kind of tough. Why not don't receive that? That's what I do with the previous. So you probably the best thing to do is if I expect the same command and I can play, let's say it's in the second, if I don't hear it didn't change it, I need to check. The reason is actually there's a way to check. And let me check it to see if it's correct. I think I made a. This one is a not good. Let me see. There we go. You see this? This is completely uncultured. Okay. Remember what? We need to check the flag first. Only the flags say that you have a new data that you start implementing your stuff. Okay, so remember we all have that? So let's see if they're gonna help. So every time you enter this loop, I'm gonna have a wait while here. I hope let's see if it helps with this situation. So wait while what? Remote can arrive flag is false. Okay. Also, this is much better secure. Is always when you do it, make sure you initialize your parameters to 0. Yeah, that's fine. Okay, basically you clear your data and you wait until there is really fresh data coming in, and then you start processing it. Okay, so that means what? Anytime you go through the endless loop, you clear out your button variable. You wait until the actually real fresh data coming in. You pick it up and then you then process from then on. Okay. So this one here, you had to plug the cable back in.
Didn't that button though? That line, like just talking about these buttons on. Is that what you want?
Oh, it's the same thing. If I use a button down here and I don't check anything,
It's the same.
you're saying, yeah, because if you go to numbers, you find out it's the same thing as 0. So, yeah, it's up to you. 0 is the same thing as that.
What about the RC? That's all.
Yeah, it's also 0. For 0, it happened to be standardized across devices. Luckily. Yeah, but yeah, true. You're correct. I take that back. Because I intend to use the remote controller, RC100, virtual or real. I really should choose this one and don't have anything unchecked. Everything unchecked. Either that or use plain old number and 0.
But I guess, deep down in the code, it's all, it all gets changed to the number value. And that number value.
Yeah, I mean, you're right. I mean, it really should be here. To be correct, should be here. Yeah, I shouldn't have used that button because that button means the button on the CM5 itself. So it is correct. It should be here. And this 0 here, you can put it 0, or you can use this. It's the same thing. And then 1, 2 is actually up, down, left, right, and stuff like that. Okay, so make sure I have backend, and you need to change because we're going to download the code. Come on. In other words, they put in English, you can only download to the cardboard through the wire. You can talk to it as runtime with the wireless, but you can only download the code with a wire. Yeah, only in the newer bot where they actually have Bluetooth. Bluetooth is secure enough that you can download your code securely down it and also play with it wirelessly. Only Bluetooth. They charge about $90 a set. Not worth it. So, so only wireless is secure enough that because when you send the data program down, you can only afford to have 1 bit out of whack, isn't it? Because the whole thing is going to go crazy. So anyway, make sure you COM1 again, and this is what you modify. I'm going to save as how about 1 or something. I don't want to change the original one. Okay. Make sure COM1 is download. Okay, and then click OK because we want to play with the remote again. So we plug it out. I'm going to go COM3, go to view output of program, and start the program as usual. Did it do that or start blasting away yours already?
That's kind of weird.
Okay.
Why didn't when I plug this guy up, you just start taking off?
Okay. Now you see it's quiet now. It doesn't do it. Okay, every time I reach because it clear out the button flag. This is much more controllable. Every time I release, it stops. Okay. So somehow you will on whatever speed you have, probably 4 speed, the first speed, something. Okay, guys. Now much better. Cool. All right. So we learned a few things today, all kind of communication ports. So now it's working properly. All right. So go back. This is a proper procedure when you do remote control. Always clear the whatever data you have. Wait until you make sure you receive really fresh data, and then start processing it. And then you don't have the problem of it missing packet or missing command, which could be crazy in RC control. Question? Yeah.
Yeah, mine's not working.
Okay, hang on. Let me stop the recording and I go over and see. Well, I thought we maybe get into the visual C part, but it doesn't look like. So at least you can see the proper. At least I want to show you that you can do wire and wireless from the PC to the car bot, right? We established that, and it can be done, except not at the same time. and wire, when you can download the code, but when you download the code, you have to use wire. But when you play with it, you can use the PC as your remote controller. Okay, so that's what we accomplished today. So okay, so so that's it for today. Time is over. We need to get out. Okay, so that's got a lecture again. Well, I got a hunch we won't be able to go through the Visual C everything here today, but we'll do what you can. That's the way it goes. So first, on the network drive, there's the TSK folder and the wireless robot folder. Just drop them all off on the desktop. Okay, and we'll get to that. So first, let's take care of the one on the carbot first. So go to TSK file folder. Should be down at the way bottom. It's a wireless carbot. Either, oh yeah, carbot one is just mine, but wireless carbot. In there, it has a remote control ID because we already got it set up properly. Already through manager, just disable it so that it don't mess up your stuff. Okay. So quick review, initial motor. This is really the same as your maybe assignment 2, if I remember correctly. So it's just we didn't do this one good last time. Let me end it out. The one that I saved is the better one. Okay, hang on. Let me drop that off onto the network drive on your there. So wireless carbot one, I just drop it onto the network drive. So refresh your network drive and bring it up to your desktop again. So wireless carbot one, we comment that out. The rest is same, except now to make it cleaner. Every time that you go through the endless loop, if you didn't push anything, basically this one here, actually this is to be exact, this one will be initialize parameter button. Okay, and this symbol here means when nothing being sent from the RC100, whether remote, I mean it's real or virtual, don't matter. Basically, it's actually the same thing as sending a signal 0. Okay, so this one we just clear them out all the time, and then we have a wait while to see if actually there's some kind of real data being sent by the user somehow. If not, it just stay there. So this is ensure that we only process fresh data. That means data actually being happening, not some stuff from the previous time in the buffer. So we're gonna wait here, and then when remote control arrive become true, it get out of the wait while statement, it pick it up whatever data is, it's saved into the parameter button again. Okay. And then if you happen to be just releasing the button after playing with it, it's gonna read nothing. Basically, no button push, and then you just stop the bot. Else, that means you are actually pushing something. Okay, either the speed setting or the direction. And then this one is just to filter out the direction only, and then it go forward, backward, left, right for the car bot. If you use button 1, 2, 3, 4, you are setting the speed. So therefore, it pick it up, it filter out from the button parameter again, and then set up the speed properly. Okay, and the only thing we have now is send to IR, print it, and then also TXD it. And last time you remember what? When you print it, it just basically just print the data for send to IR. So remember in the output window, it print out correctly because send only just raw data, basically 1 byte pretty much. Basically, it sent out as RS-232 protocol. And the output window knows what to do with it. And then it printed out. But when you do TXD, you remember it's a ZigBee packet that it sent out, which has 6 bytes. So it have all kind of things in there. So the output window say, what are you talking about here? So it printed the best it can. Okay, that's kind of equivalent, and I'm talking to English now, right? I explain things to you. And as I talk, I switch to Vietnamese and I start just discussing, explaining this guy in Vietnamese, say, what? Basically, it's the same thing. Because all the sound just, the wire, either wire or wireless, it's just a medium to send out little bits, right? How you make send out of all little bits is up to you. It's up to your decision how to parse the message. I mean, the fancy name is to parse the message. Okay, and we already done that, show how carbot working and remotely and show the problem there. The distinction, well, not a problem. The distinction between print with line, which is RS-232 protocol, versus TXD, with send out a whole ZigBee packet. Okay, today what we're going to do is to go into Visual C Express, and hopefully it will work. And usually, because that's a complex software, to see if it works, and then go through the example. We go into the detail. And what it does with the Visual C program, basically later, if you want to, you can make your own little scheme. Instead of using their packet, you use your own little scheme of messages. So essentially, kind of open up your window to do things on their own. If you were in a company somewhere where you need to do some specific encryption, hey, this is the place to do it. Because the wire or wireless is sent out in the clear. But before you send out the clear, remember how you play with the message where you shift ID up and then the position at the end? Only you know that. Right? Only you know that. You had to tell the other people, this is how I package my data. So that's why that's a basic encryption, is you knock your own key or your own key. Except the NSA people seem to figure everything out already. They have more powerful computer and smarter people. So okay, so first carbot one, let's download this one down. So before I forget. So remember carbot is going through the wire. So CM5, go download it. So I'm gonna save the one to be sure and download that. So that's all we need. So on the carbot side, that's done. And then the rest now you can even turn it off to save some battery. And we go to the Visual C part now. Okay, so we actually need to get oriented a little bit actually on the PowerPoint side. So PC6 data logger, I'm going to put it down so I can access the wireless. So we've done all that. We talk about the wire callers, and we talk about the situation. So remember come on. Why would it finally get it moving? Okay, so we're about to talk to wireless robot.zip first. Okay, I already made it. I already unzipped all this for you essentially. And so in the wireless robot folder, you should see this. And go to, you see it? Okay. Go to code. Go to app. And there's the data logger VC 2010. Yours could be different. But if you look at the VC Plus project, it should say data logger with a plus plus symbol or something. Should be, right? The extension, the VCX project. Okay. Okay. And it should work. So let's see. I already tried twice here on my computer. So it will double click on it. It knows to pull up Visual Studio Professional 2012. It coming up. Hmm.
I'm getting a little.
Yeah. Yeah.
The general.
Choose no. Click on Visual C++ development setting. Okay. And then start Visual Studio. It's very complicated setting, and as you see it, it creates your profile, all that thing in there, and then but the thing is, it erase everything from here. So who knows? You may have to do it next time. I don't know. I don't know if they create the student profile is a roaming profile. I mean, it doesn't matter which machine you're on or not. We'll see. But it takes a long time to set it up. Okay. Eventually, hopefully. Oh, they bump around with my projector and it's out of focus. I need to email them about it. Okay. Is it coming up? It's still cranking.
Oh, yeah, we got something coming.
Yeah, eventually it will ask to see if you want to update 2012. Definitely you want to update 2012 because the profile was set up for 2010. Oh, you found it? Okay. Just tell it to update. Yeah. Okay. So me too. I need to update. And hopefully it will do it. Okay. So when they say updating, one succeeded. Oh, update the Visual Studio. I'm sure. Yeah. And if you look down here, there were hundreds of files it updated. You look at that. So just using it is hard. Okay. So when it says Visual C++ project one succeeded, nothing failure is good. Hopefully it doesn't say fail because if it doesn't fail, it's kind of hard to troubleshoot. And then you may just have to follow me and trust my word for it. It's gonna work. Okay. All right. Is it up like that? Okay. Go ahead and minimize it. We won't need it yet. We actually run the exe version of it first. So hang on. Don't do anything yet. Let me check. Make sure my stuff working. Go to the debug version, debug folder now. It should have a data logger.exe from some time back, right? Yeah, don't run it yet. Just leave it there. We'll run it. So basically, we're gonna run the exe version. That means it's an older version of the software to run it, just to check to see how the software is working. That's probably about the only time we have today. Okay. Okay, but I need to go in and explain a few things first. Hang on. Okay, so let me pop this one up just to explain. So if you pull, yeah, you can go back here. You probably can follow. So if you pull up the visual project, everything properly, there's this folder, this window here, data logger. So if you click on the arrow to open up, you have header file and source file. These 5 are the ones we're going to be looking at in detail. Okay, so in Visual C, you always have header file at the .h file, and then the .cpp or .c, depending on which language you're working on. Most of the robots stuff are kind of low level, so they use C for the hardware. Okay, so the header file are usually the one that have all the settings, the different constant, different addresses, different baud rate for communication and stuff like that. So go ahead, and if you double click on any of these, it will pull them up in here. So double click on ZigBee HAL, it come up. Double click on ZigBee H, it come up. Double click on main C, coming up. ZigBee HAL coming up. ZigBee C. See all 5 of them here. I will go through that one by one. ZGB how.h. So click on that, you can see them. Oh, do you see the numbers here? You do?
We don't.
Okay, if you don't, and then go to, if I remember correctly, tools, options, and it's in the text editor. Go to all languages, and there's something down here called display. Your line numbers may not be checked. Checked it and click OK. So now you see the numbers, right? The statement numbers. Sometimes it will help because all my PowerPoint kind of refer to those numbers, so it will be handy. Okay. So you can see that the header file usually, these are if defined, you don't worry about it. But basically, usually it lists out the functions that it will define in usually ZigBee how.h, which is how, I don't know if you and I know, but that's hardware layer. HLL, I mean hardware layer. Okay, so go down there. So this, basically the H file will define all the function that you plan to use. Okay, like on a low level, you need to open that COM port, right? So there's something called ZigBee how. It expects 2 parameters coming in, 1 integer called development index, that a COM port, 1 floating number with the floating point number, which is the baud rate, which already preset and everything, but you can see. And then it will return an integer. So you, in the hardware layer, you always have something that open a device, basically open a COM port. Obviously, if you open something, you better close it, right? So for all the proper software. And then you remember what? It need to be able to send the ZigBee profile, TX, the ZigBee packet, but also it need to handle how to receive. So that's about it as far as communication goes. And then it need to pick up some kind of unsigned character, P packet, and how many number packet, all of that. So you can see that say what to send and how many packet I see in there. Okay, so these are just define that. It will jive with ZigBee how.c. So in ZigBee how.c, these include files, usually you keep them alone because we're using Windows serial programming, standard IO window, you keep that. You see, it's always include that .h file that we already talked about so that it knows. And then this is a handle something for the window. Basically, this is one you keep alone. So this piece of code back here, if you want to manage something, you leave it alone. Okay, and then you can see that it have all the previous 4 functions that we talked about defined in here. Each of them a little pieces, a little bit subgroup. So remember, same thing as in when you program on the robot task file, you have a main program, right? And then below you have a bunch of functions. So these are the bunch of functions. Okay. So
One of these main programs.
the main.cpp, the main program. The main program is the one that when you start a program, it runs first and it calls whatever is needed to call the rest. Right now, we're talking about the header layer, ZigBee how, and then we see. Just go overall. I won't go into the detail yet at this point in time. I want to run the exe version just to see how it's working. That's what we're doing here. Okay. So, but what I want to do is the .h of ZigBee how will correspond to ZigBee how.c. Usually that people keep up. You don't have to, but usually you can see that you better keep the same name, right? Yeah. So you know what one to call. So you can see that right now I won't go into detail, but you see there are much more detail, all its glory there what is calling, what is TXD, what is receiving, all that. Okay, so that corresponds to that. Okay, so so that's your hardware layer. In the ZigBee.h, they have more stuff. Initialize, terminate. Which is, wait a minute, you say, oh, didn't I have something like start and thing here? But that was at the low level, at the COM port level. This one more a higher device level. Okay, in there where you have the TXD data, this one is much closer to the task program. Remember the task program when we have remote control TXD on the left side and then you send some kind of data on the other side? Let me pull it up. This is kind of my old one here. Don't matter. When you do this, you're sending a data over, right? Here, same thing. Where did it go? Oh, I switched to main, that's why. See, it show you, hey, TXD, you're sending some kind of data. And then remember the check here, that's the flag. We're missing, remember remote control arrive? Let me put it up here. Oh. Ah, wrong one. The one on the desktop is the correct one. Remember the task, what, arrive, RxD, essentially TXD. This is them, the real thing in C. You didn't see initialize terminate because when you turn the bot on, it does that for you. But you see here that TXD, that's a remote control TXD, the real function that actually does it. The check is the one that actually gives you that flag, true or false. And the RX data is the one that sends the data. All this is on the PC level. Remember when you play with the manager, how you click and sending over? Yeah, this guy actually behind it. And then also, of course, they need to build up the window things to interface with it. But this is the real data that actually sent out, okay? So that's a ZigBee.h. Yeah, right. And then remember, it sent all the button. You see that kind of weird? Didn't we send? No, we did. Remember, button up is really sending the data over one. We're really sending one over and then two button doing up, down. That's what it is. Okay. But you can see that you have to define everything very clearly, explicitly when you go down to the C level. So basically, because we are doing the PC to emulate the real RC100. Every time you push a little button on RC100, it have an equivalent of these functions, it send it away. You didn't have to take care of it, right? You just push the button. But now you can see it here. Okay, so that H. And then, of course, ZigBee.C corresponds to it. And then it has more detail because that H just lists the different functions that you need to do. But here, it actually has the gory code. You see how it packaged 555, FF55 low byte, the inverse of the low byte, high byte, all the gory detail right there. See it? Oh man, right? Yeah. And then once you know how to do that, that means, hey, I can cook up my own little thing here. Okay. Yeah. Because that's what you do so that nobody can listen to your little packet because they are expecting 55, you send in 56. So they say, hey, that won't work for me. Okay. So that means what? Each of you can even send broadcast, but if you know how to modify here, you can broadcast as much as you can, but only your bot knows the right code. Okay? So this is a kind of intro to data encryption here, but it's just really just communication protocol. As long as two parties agree, we're good, right? Not even if you for five. As long as you agree on how the PC is going to talk to your bot, you can make it in own unique way. And you don't tell anybody, nobody knows. Unless, they can have a packet sniffer and they can look certain pattern and say, oh, that kind of repeating there. I think the guy is trying to do this. Okay, and then you do. Okay. All right, just want to show you the main thing so that it's like this. Okay? All right. So usually there's some kind of .h file that corresponds to the .c file, with essentially .h is kind of give you the big picture of the naming of different functions that you plan to use at the hardware level, low level, and then the actual name .c will give you all the gory detail of how you manage the actual data structure, they have you send it away and all that, okay? Like initialize here, it show you, yeah, I'm just set it as 57.6 kilobytes per second here. This is where you set. So you can go here and change to 112 kilobyte or yeah, that's a baud rate right there. Okay, all kind of those things. Okay, we'll get back to it, but I just show you the big picture. And then finally, you have the main program, which it include all the ZigBee.h stuff that you use. Okay, and then the main program here, because in the main program usually you need to which port to open, define all your data, integer. And then watching for keyboard, because when the main program runs, because you're gonna have different COM port for different of these things, right? Oh, the ZigBee channel, remember either COM1 or COM3 and all that. You have to tell the PC somehow, right? Just like you did it when you go to the task tool or the manager, hey, I'm looking at COM1, COM3. So all about here. So basically, you can see that the interface. You see that so. We go much lower level where you see the main just had the main. And then if you see somewhere, let's see, here we go. You prepare the TXT data and somewhere over here, let's see. This is just preparing the TXT data, different condition. And then I'm trying to find where the function is called. It's probably at the bottom. Here we go. So you prepare your data, boom, you change the data. You just invoke the function. Okay? All right. So let's just minimize that one for now. Okay. So what we do is we want to see. We'll download the wireless cardbot. I just want to see how it's working now. Okay. So on the bot side, remember. Remove the mini jack so it can talk wirelessly. Turn it on. Okay. And make sure in play mode and run the program. Now you remember what? What is this dongle? For me, it was COM3. Was it COM3 for you guys? No. COM1 is always a wire.
Oh yeah, this is COM3.
Yeah, whatever COM3 for the dongle, the USB dongle. Yeah. Okay. So remember that one. All right. So now we can go in. So basically, we're just gonna play with the program now. So somebody compile it. It have an exe version. It's gonna an executable version, so it can run it. So basically, just go to that folder that you put on the desktop. You're not there yet. Well, I might still have them here. I just opened up too many. Yeah, I did. So remember, go to the debug version. There's a data logger.exe somewhere, or if you don't have the extension, it probably should say application. And let's see if it works. So double click on it. Uh-oh. You don't want to do that. Hang on. So that, no. We will do that later, but go back out, go to wireless cardbot code. You say bin. No, that's not that. Oh, sorry, in app, there's a folder that say wireless data logger binaries. Okay, that one is prepared much better. It didn't run here until you run the program, but we run it here. So you should see a bunch of them. I think the VC6 and V10 have some problem with the new Visual C 2012. It doesn't look like though. Let's try this one first. No, it don't want to work. Try the VC6. Okay, you need a pop-up one. That one works. So I need to update all profile and recompile them again. Okay, so it come up like this with a black screen, right? Okay, I don't know how much PC you work on, but this is what the MS DOS window or the command window, right? Way back. Yeah. Okay. So remember, we are for me, I'm COM3. So oh well, it's already 10.5. We probably just show how it works. So you push 3 because that's COM port 3. Hit enter. If it responds with COM3 later, when I explain the main code, that means it's actually found a COM3. There's a real device there, and it's talking to it. Okay. Okay. So in the main program, you have different code to handle if somebody entered the wrong COM port. So if you see this, okay. So we are okay. That means we use. Basically, also because this is data logger, so whatever we play with, it will put it on the file for you. Okay. So output to file, yes. Put Y. File name, just put in a file name. Like for example, I'm gonna put test.txt. So it will create a text file called test.txt in the same folder where you invoke that binary. Okay. Actually, if you hit return here, it's gonna open the file already. And you see it just popped up test.txt in that one. Is that showing you okay? Okay, it's open the file. So it's open the file, and then every time we play with something, it will save things in there. Okay, and then this is a bare minimum user interface, right? So now you're ready. It doesn't tell much. To quit, just basically you don't want to quit yet, so don't put anything. And what it does is right now, if everything is working, this command window is talking to COM3 port wirelessly through this ZigBee dongle. Let me put it here so we can play. To the carbot, which already right now should be running the carbot reboot wireless carbot. Okay? So if everything work together. Right now, okay. Now we have problem using the arrow key because the window at this level it doesn't command doesn't know the extended keyboard character. Okay, so you look at WASD keyboard. So W is equivalent to our up key, S is down, A left, and D is right, essentially. Okay, this is old school computer. Real good. I don't know.
You can't say this in 3 years.
Yeah. So if you push W, it should run forward. And every time I push DW, it does that. So everyone left and right. Yeah, it got stuck in there. So this old code is no good. Push T. So we need to fix that up. You did the right port? You did COM3? Did you previously, through the manager, set up everything so they talk to each other? I did not check. I mean, we checked the other guy. But anyway, let's just follow this so that at least it's recorded in the lecture.
I pressed, I guess, T.
Yeah, T will cut that. Or if you enter, so basically, I do it again. Okay. The W, if you enter something wrong, it quit. If you enter, basically this one here, if you enter the junk key, it sends junk over and it stop essentially. See that? Right now I'm doing W, S to go down, A to go left, D to go right, and then just put any key on the keyboard. Because basically you see it keep on running right, left. When it says junk, it's null, it's sent an equivalent 0 over, and that stop it. You know, that's equivalent to our no button symbol. Okay, so it does that. Okay. When you read the code, you're going to see that, yeah, we can also span special packages. Special package. And you can send different numbers. Basically, message is just a bunch of numbers. So you can use WASD essentially to simulate the RC100 file case. And you can see that, hey, in the main program, I can build in. So if I push the number 1, 2, 3 up on the top row, it should be able to understand that. It's not in there now, but you can do that. So what we do, let's see if I do it or not. Oh, it did do that. Okay, I did. So buttons. Okay, go to 4 then. That means it's sending the button 4. Now if you do WSD, go faster. Here we go. So all of that. Hey, all right. Oop. Okay. So basically on the keyboard, WASD for up, down, left, right, 1, 2, 3, 4 for the speed. So it functionally it's the same thing as the RC100. Okay, just a keyboard. Really old school. All right. It also have another feature is it transmit special packages. So if you put T and then this little thing come up, basically you can enter your 16-bit message now. You can send in a decimal number, which you can do. Just tap in 1, 2, 3, 4. That 1,234. Hit enter. It pick it up as 1, 2, 3, 4 somewhere. So they have that part. Interesting. It's lost in there. It pick up 1 and make it no. It pick the last number 4. So if you send decimal 23. Oh, I'm sorry. Oh, you need to push T every time to make sure you enter that. So let me see. 1, 2.
How do you stop the chat?
Okay. Look like I have a problem here. It should not have done that. It just send a number and this one receive it. It's not doing that right now. Okay, let's try hex. Maybe it work better. So in hex, you had to have 0, small x, and then a number. So 0, x, and then let's say put A, B, C, D because that's the correct one for in hex. Uh-oh, mine not working. It keep on. It's not the carbot side is feeding wrong here. So I'm gonna send it wrong. I think I have a problem. You see that cmdatalogger.tsk?
Yeah.
Let's download that one. I think it works better with that one. We modified too much, and this is a problem. So just download that one. It's gonna work with that one. Some time ago, it worked. So just use COM1 because we are using a wire. Let's download that one.
I think with the sound, I think that our data flags, how we kind of had that.
Yeah, I think we messed it up because here it didn't check for that one. So the code is different. Sorry, we change it for something else, and then we do. So now it's downloaded. That remove that one. Let it run. We'll see. We haven't changed the COM3 port here. That's hopefully it's still working. Let's check. It's sending, but it's not doing anything. I may have to quit. Put the space bar to quit completely. And then run that data logger again. It may clear up the window frame. Oh, sorry. Data logger v6. Let's do COM3. Yes. Test.txt. Okay. So that put speed of 3 here. It transmitted. Now I'm sending the data, but mine is not working. Did I send the code down? I should send it down.
Well, I'm receiving it.
Is it moving? Not moving at all. Ooh. Okay. We got completely failure here. I tried the other day and I got it working, but now I'm not.
But this data logger code isn't supposed to, right?
Yeah, supposed to make it run. So we'll see. Okay. Well, it's 10:16, so I need to go. So it look like this is today's failure demonstration here. So we'll try next time.